Hello everyone, and welcome to part 3 in this series on creating realistic materials in Blender's Viewport using GLSL shading. And I'd like to start out by discussing the Ambient Occlusion shader. And in Cycles, the only way to customize the Ambient Occlusion shader is its color, which I suppose is supposed to represent the ambient lighting. I don't know, I never really use it. I would much rather be able to control the value, or how dark the ambient occlusion effect is. And I'm beginning with this cloth simulation, and I've added the velvet shader that we made in the last one. And ordinarily I would say to bake out your ambient occlusion. You'll get the best result that way. But in this instance there are 6,000 vertices, or nearly 6,000. And because it's so many, I'm going to use the decimate modifier to reduce the amount of vertices. So I'll just slide this down, and I've turned the wire option on under the object info panel so that you can see the retopology as it happens. So I've applied that, and now we have this really messy mesh that would be very difficult to unwrap in the instance that you did want to bake your ambient occlusion. So let's use a different method. Let's switch from object mode to Vertex paint, and then go from textured view to solid view. And now I'll come back over to my object info, and I'll just turn off that wire option so that we're not distracted with all of those lines. And now I'll select Paint and then Dirty Vertex Colors. And then I'll check this box that says Dirt Only, and that reduces that effect to just the really sharp angled creases, the same areas where ambient occlusion would take place anyway. And actually, if I come down underneath of Shading and I check the Viewport ambient occlusion, you can see that it's really using the same vertex data that the Vertex paint is using anyway. It's basically the same. But with the Vertex paint, we can actually see this in the game engine, whereas the Viewport ambient occlusion, you cannot. So let's make a few more adjustments. We'll increase the blur iterations. I'm going to set this to maybe like 4 or 5. It might be different depending on what the model is, but I'll stay at 4. And the blur strength I'm going to take down to 0.5. And I think that should probably work in this instance. Again, but depending on what your model is, you may need to make some adjustments there. But since I'm happy with these settings, I'm going to come over to my Object Data panel. And down under Vertex Colors, we see that we've added this one. It's called COL, just stands for color. And in the instance that you have a lot of different Vertex paint effects applied to a model, you would need to name these. I'm just going to name this one AO for ambient occlusion. Now I'll switch back to textured view, and down in the node editor underneath of the velvet shader, I'll type Shift A and go to input, then geometry. And in this last little drop box at the bottom, I'll select that vertex data that we created. It's called AO. And now I'll type Shift A and go to Converter Math. And I'll set the type to Power. Then I'll plug the vertex color into the first value. And if I plug this directly into the material output, you can see that a value of 0.5 looks pretty good. If I take this down to 0, it's no ambient occlusion effect at all. And then if I take this up past 0.5, it just gets darker and darker as you go. So it will control the strength of that ambient occlusion very nicely. So now I'll use B to box select that and use Control G to make that into a node group, which is probably the easiest node group we've had to make. It's just 2 nodes. And I'll plug that second value into the group input node. And if I use Tab to go back out of edit mode, you can see that we have this really simple shader. I can rename this over here under the properties to just AO. And we just have this node that has a value slider that controls the strength of our ambient occlusion. So now I'll type Shift A and go to Color and Mix RGB. And I'll plug the ambient occlusion into the second input, and the velvet shader will go into the first input. And then I'll switch the blend type from mix to multiply and take the factor all the way up. And now if I increase the value on the ambient occlusion shader, I can add a little bit of contrast to the model and fill in those shadowed areas. And I should note that if you go too far in the opposite direction, it will invert that effect. So you'd probably want to stay away from that because it would lighten up all of those areas. But otherwise, I think it works pretty well for models that you can't unwrap and bake the ambient occlusion. One more thing I'd like to mention is that you may run into some problems with models like Suzanne, for instance, whose eyes are not connected. And that's because the dirty vertex colors won't read these areas. Areas need to be connected by vertices in order for the dirty vertex colors to create that effect. So, just to show you, I'll create a new material and I'll add the ambient occlusion shader to it. And so the first thing you need to know is just by adding this shader to a material, it's not going to work straight away. If I give this a value of anything, it'll just turn Suzanne completely black. And that's because we haven't given her any vertex data yet. So we need to go over to our vertex paint and then go to paint, and then let's switch to solid view so we can see this, and dirty vertex colors, and it's already set to the settings that we had before, which should work fine. And I'll call this AO, just like we did before. Now I'll go back to textured view, and if I give this a value now, then you'll start to see the ambient occlusion, but you don't see it around the eyes. And you won't, again, on any part of your mesh that's not connected by vertices. And there is a little bit of a shadow on the outer part of the eye. It just doesn't extend onto the inner part because it's not connected. And so that's one thing you would have to watch out for. So now let's move on to the glass shader. And this will be one of the more complicated shaders that we create in GLSL, mostly because we can't really create all of the effects of glass. For instance, these caustics. Caustics are the refraction of light through the glass onto the surface of the table. That has to be baked because we won't be able to see that in the viewport any other way. And then there are these different distribution types. We can't really do anything there. We will make it so that we're able to change the color and also the roughness. And if you notice with the roughness, just like with the glossy material, at a value of 0, these reflections are really sharp. And then as you increase the roughness, then the glass looks a little less transparent. Everything is blurry. And that specularity, or the glossiness of it, becomes much more broad on these areas. So we're going to try to simulate that in GLSL. And also the caustics, as you increase the roughness, that changes as well. And then the IOR, we really won't be able to do much with that in GLSL. There is, I believe, a script that will simulate the index of refraction, but we're not really going to be dealing with scripts, so our shader won't have any IOR or index of refraction. So now let's move over to Blender Internal, or the Blender Game Engine, whichever you prefer. And I've already got the scene set up. I have my teapot, and it's sitting on the surface, which I've baked that texture out so that it shows the caustics. Again, because, as far as Blender has already come with the viewport, and even with everything that 2.8 promises, we're still really far away from being able to see things like caustics and transmission in the viewport. That kind of viewport rendering is probably pretty far down the road for us. And of course with baking, that essentially just paints those shadows and light onto the table. And I've baked 2 textures actually. I created one with the sharp reflection and one with the rough surface. So now I've just mixed those with a mix RGB node. And at a value of 0, it's the sharp caustics. And if I slide this up, then they become a little more blurry. And that's in the case that we want to increase the roughness on the glass. We'll be able to change the surface of the caustics as well. I also want to mention that I know that there's a lot of discussion in the comments on these videos about what's physically accurate, but this isn't exactly demonstrating PBR. It's not physically based rendering. I see this more as an art style rather than the science of PBR. But I encourage you guys to research and learn as much as you want about PBR. It's just not exactly what I'm demonstrating here. And before we move on to the actual glass material, I want the surface of this table to have a little bit of a reflection. And I've already created the table reflection material. But the way in which I'm going to mix it is a little different. And it also brings up another point that I'd like to discuss. So I have this material that has an HDRI image and it's set to reflection. And I'm just going to mix it with these textures that I baked out. And then we get this surface that's really reflective, which doesn't look very realistic. And I said before that I didn't like using cycles nodes for a very particular reason. And I'm going to demonstrate that now. So this material is in Blender internal, and this is the just regular reflection material. And you can see how it's mapped. Now if I switch over to the cycles material, I've just have this geometry node that's set to reflection, and it's using the texture node from cycles. If I apply this, now you can see that the reflection is applied really strangely. It's sort of wrapped around and it's doubled. I don't even really understand what's happening. There seems to be like multiple images, and it just looks really weird. And while it works perfectly fine in cycles, it just happens that all of the nodes they're not unified. So they don't work the same way in cycles as they do in Blender internal or the game engine. So with that being said, I'm just using this as a visual example, but there are a lot of cycles nodes that I've found act a little wonky or buggy in GLSL. However, there is one node that I always use for flat surfaces like this when it comes to reflection. So I'll switch over to Cycles Render, and I'll type Shift A, and I'll go to Input, and I'll choose the Layer Weight node. This is the one exception. I'll plug the facing value, or facing output, into the Mix Factor. And now let's go back to Blender Game or Blender Render, and I'll change the blend do like 0.02. And so what this does is now if I'm looking down at the surface, you don't see a lot of reflection. But then as you view it at a sharper angle, the reflection becomes more intensified. And that's how a real-world material would work. And I know that we were talking about how this is not PBR, and that this is more of just the art style. In this instance, like, I do like making these types of flat surfaces act a little more like realistic surfaces. Okay, so now let's move on to creating our glass material. So I'll select the teapot. And then I'll create a new material, and I'll just call this one Reflection Sharp. And so now I'll take the intensity of the specularity all the way up, and the hardness I'll take all the way up as well. And I'll switch the type from Cook Tour to Blinn, and the IOR I'll take all the way up to 10, and this gives it a nice sharp reflection, like the just like we did with the glossy material. We created the sharpest reflection, had those really sharp specularity as well. And now we'll give it a new texture, and we'll switch it from UV to reflection. And I'm just going to be using the same HDRIs that we have been using that I started with in the first part of the series. Now the second material will be called reflection rough. Okay, so let's maybe apply it so that we can adjust the specularity. I'll take the intensity all the way up, and the hardness I'll set kind of low, maybe value of 25. That should work pretty well for a rough reflection. Okay, so now let's switch over to the texture, and we'll add the blurred texture and set the coordinates to reflection. And this is basically starting out the same way as the glossy shader did. But we're just going to be doing a few things to customize it so it behaves more like glass. We need to create a new material, and this one I'll just call nodes, and this one will be the one that we're using to mix all of the other materials together. But one really important thing to do with this material selected is you need to scroll down and find your transparency setting. Make sure that you check the box. That's very important. Depending on where you are, if you're in Blender Internal, that might be in a different area. I think it's closer to the top, but it's in your render settings, or in your material settings rather. Just make sure that you check that box. And so now under the material, we can select the Use Nodes tab, and then assign that to the object. And so now, again, we're going to start out basically the same way that we did the last time with the glossy shader. So I want to, in the material node, to open the sharp reflection, and then duplicate this node with Shift D. And in the second material, I'll open the rough reflection. And now I'm just going to mix these two materials together with a Mix RGB node. Okay, and now I'll type Shift A and add an Input Geometry node, and Shift A again, and Vector Normal node. Now I'll connect these together with the normal output on the Geometry node, and then Shift A again and choose Converter Color Ramp. Now I'll use the dot output on the normal node into the color ramp, and then pull the black and the white closer together. Maybe not too close, maybe just a little bit of a space between them so that the transition isn't too sharp. And then I'll plug the color into the alpha on the material output. Okay, so this gives a really sharp reflection there around the border of the object, and the center is transparent. But we don't want the center completely transparent. We want some of that reflection to be over the whole surface. So we'll box select these three nodes and move them out of the way. And we'll type Shift A and go to Converter Math. And we'll just drop that in right after the color ramp. And now I'm going to type Shift A again and go to Input Value. And then I'm going to plug this value node into the factor on the math node, and also the factor on the Mix RGB node. So now this one value slider will control the roughness of the glass, and as I increase the roughness, it will become less transparent, and the reflection will, of course, become a little more blurry. And then if I take it down, it will be sharper and more transparent, but it looks a little weird. It seems like you can't really see the table underneath. And oh, of course, I know why. So we need to click on the Object Info tab over here, and we just need to click this little transparency checkbox, and now it shows up properly in the viewport. Right, so now if we increase it, then the teapot becomes more rough in its reflection and also less transparent. So that's working nicely. And it's also added a little bit of a reflection over the entire surface so that the center isn't completely transparent, which doesn't really look very good. Alright, so now we want to make it so that we can change the color of the glass. So let's create a new material, and we'll just call it color. And we can make this shadeless. And now I'll select the teapot again and go back to our node material and duplicate this node with Shift D, and then open up that material, which is just called color. And I will mix that with this Mix RGB node. So I'll just duplicate this with Shift D. Okay, and so I'll set this from mix to color and take the factor all the way up. And so now if I change the color of this material, it changes the color of the glass. And then even if I increase the roughness, you can see it even more because the more of the surface will take on that color. And so that's working very well, except there's one problem with this in that you can't change the value. So if I set this all the way back to white, and then I switch this down to black, the color doesn't change at all, because you can only change the color, not the value. And we want to be able to make it darker. Personally, I think that darker glass implies thickness, which makes the glass look a little more realistic. So we'll create another material, and we'll just call this one value. And we'll make this one shadeless as well. And go back to our node material. And then I'll duplicate these two nodes. And then plug this Mix RGB in, and then connect this one to the material output. And this time I will select that value material. And I'll set this blend type to multiply. And now if I change the value on this to something a little darker, then the glass looks darker, which again I think implies thickness because thicker glass lets in less light, giving it a darker appearance. One thing you would want to do though is, I guess, make decisions about your color and your thickness before you bake those caustics. Because if you have green, thick glass, that's going to affect the color of the caustics. Alright, now let's box select all of these nodes except for the material output. So we'll just type B to box select. And then we'll use Control G to make those into a node group. And as for our inputs, we know we want the color, so that'll be the first thing that we add. We'll use the color on this color material, and that adds it into that input, and we can just leave it called color. And then we'll take the color from the value material, and we can rename this one. We can call it thickness or value or whatever you really want. I'll call it thickness. Maybe I'll just call it value just to keep it simple. And now we want the roughness, so we can delete this value node. And we'll just plug the factor from this Mix RGB into the input node. And if I hold shift and left click and drag that through the line, I can create a rerouter and plug that into the input value on the mask node. And we'll change that from factor to roughness. Okay, so now I'll press tab to get out of edit mode. And we can take a look at our node material. And so now we are able to change the color. And we can change the value to make the glass look a little thicker. And we can of course change the roughness, which affects how blurry the reflections get and how transparent the glass gets, and of course how specular, how broad that specularity is. So again, you'd maybe want to bake your caustics after you've decided on what your glass is going to look like, because in this instance the caustics would have a little bit of a blue tint to it. But otherwise the glass material looks pretty good. That will be the end of part 3, and we'll probably finish this up in part 4. So until then, thanks for watching, and I'll see you in the next one.